Hello. Yesterday we published a blog post on a Group B preview of the World Cup. So I wanted to jump in and show you how we built that report out using Shipyard and Hex. So let's dive in and look at that. So starting off, we used the data from Maven Analytics. So you can see on their website here, as I'm showing on my screen, or on LinkedIn, they have their Maven Analytics challenge that they have. I think they host it every month. And this month they hosted it using the World Cup. And so they posted some World Cup data that you can see here on their website. You can preview that data and show all the data that they've given to you to work with. So this is what I downloaded from. So I knew I wanted to download this data, get it into BigQuery, and so then I could work with it inside of Hex. So that was kind of the flow that I was going for. So jumping over into Shipyards, you can see I already have this fleet built out because this is exactly what I used to get my data into BigQuery to work with in Hex. So you can see I started off using our HTTP download file from URL. And you can see I just put in my file URL, which was this data, or was the URL from Maven. So I just clicked on download, right-clicked, copy the link address, threw it into Shipyard here, and just named it worldcupdata.zip. I added my next vessel, which I decompressed the files. So Maven sends you the data inside of a zip file. So I used this to unzip it. So you can see I just used the compression type was zip, local file name, just through that file name that I named from the first vessel. That's all you need there to decompress that. So then that's going to decompress all those files into a folder named World Cup Data inside of Shipyard. But it's going to decompress all those files into those individual CSVs that we need to put inside of BigQuery. I did a list all files vessel here just to make sure that the files were in there. And then went through and made a vessel for each table to go inside of BigQuery. I'm just going to click on one of these and show it. So you can see the dataset name I named in BigQuery was Maven World Cup Data. I'll show that in just a moment. I named the table Historical World Cup Matches. I was looking for an exact match. The file was named World Cup Matches inside of that zip that Maven sent over in the World Cup Data folder. And I just did an override data. Because this data should not particularly change. They did add a table afterwards that I had to add in, but the data really shouldn't change or do anything crazy, so I just did override data to work with that. And if they do go back and add in the matches that are being played currently, we can always run this again, and it's going to override that table with the new data that has the actual matches that are happening as we speak. And then I put in obviously my Google BigQuery service account JSON. So I did that, of course, multiple times here. And so what I want to show now is I want to pop over into the logs to show this thing as it actually ran. So looking inside of our logs, you can see here's that full run that happened, the download data, the decompressing the file, so unzipping them, and then each table going into BigQuery. You can see those ran concurrently. So you can see this whole process took around 1 minute and 16 seconds. I downloaded the file from Maven, decompress it from the zip, and then actually get it inside of BigQuery. And you can even see with my list files blueprint here, you can see there are those files that I grabbed from Maven inside of that World Cup data folder like I mentioned from before. So now looking inside of BigQuery just to show that they're there. So you can see here's our Maven World Cup data set here. And you can see, if I clicked any one of these, I can preview that data. Here's that data that we wanted to work with there. So now our data is inside of BigQuery, which is where we want it. So now I switched over into Hex. To do some analysis, to do some manipulation of the data to get the fields that I wanted. So let's jump over into Hex and show that. So I scroll up to the top. Of course, we need our trusty pandas and NumPy, just like almost every Python workflow. You're going to need those. So import those in. And so you can see the first step I did was just taking those players and just grabbing the ones that are in our group. So Iran, United States, England, and Wales. That's the 4 teams in Group B. So just filtered those out that way. I had to pull in a new table because I wanted to make sure inside of my analysis I showed which players from each team were in a top 5 league. And so you can see the list of those teams there. I just went to Wikipedia, copied those into an Excel spreadsheet, pulled that file in. You can see over here inside of files, there's that top 5 leagues there. And so again, what I did here, you can see that I pulled in whether the player was in a top league and marked that. So you can see over here on the side, you have the 0 for if they're not in a top league and 1 if they are. So you can see a lot of the United States players here are playing from Nashville SC, New York Red Bulls, Inter Miami. So these are all teams in Major League Soccer or MLS. Those are not top leagues, and that's not a top league in the world. So they all received a 0 there. If I go back to the first page of data, um, it's going to show a lot of the English players, I believe, which play a lot in the Premier League or maybe the Bundesliga or Serie A. And a lot of those players, of course, are in a top league. So you can see Tottenham Hotspur, Chelsea, Manchester United, all those are in the English Premier League. And so those are all marked as ones. So we have that we have that binary code there for us there, the 1 or 0. So then I was able to come here and make a chart that's actually inside of my blog post that I made. So here, so you can see that England obviously has the most players in the top 5 leagues, followed by the U.S. and then Wales and then Iran. So there's that first graphic that I used inside of my blog post. So then scrolling down, I then wanted to look at see like what the FIFA rankings were for each team. So Maven had that inside of their groups table. So I filtered again to only get the teams inside of Group B. So you can see the resulting table here, and then threw that onto a chart here. Again, this is probably my least favorite chart that I threw on there. But it does show that England should be favored in this group, followed by the United States, Wales, and Iran being pretty clustered right there from 16 to 20. And if my chart was properly marked on the side, you can see there's a little bit of a jump there. The U.S., Wales, and Iran will probably be up here somewhere. But it still does show what we want to show there. So then next, I wanted to look and see what FIFA ranking the teams that were not in the World Cup were. So we have a data set that's showing basically what matches each team has played in the past, forever. I filtered that down from matches from 2010 onwards. But say Nicaragua or Ethiopia, Lithuania, they generally don't make it to the World Cup, so we don't have their FIFA World Rankings in our data set. So I pulled that in from a CSV from FIFA's website. And then I went through here and I just made sure that I had basically, because the data that Maven sends us basically has the home goals, away goals, and that's it. So I went through and made sure that I had it marked whether the team won or lost. And so you can see I did that multiple times here, whether our team that was in our group was the home team or the away team, and then for the different tables of World Cup, prior World Cup matches or prior international matches that were not World Cup. So it could be a Gold Cup, that could be a friendly, any match like that. I wanted to make sure and go through that I marked whether they won or lost. And then I added on a join to put in the ranking of the team that they won or lost or tied against. And so you can see the result of that here. So this is not World Cup games here, and if the United States, Iran, Wales, or English were home, so you can see the United States won against a team that was ranked 167th in the world, and they played that team 3 times, which of course happens a lot because we play a lot of friendlies against teams inside of North America. So I believe that was Cuba, if I remember correctly. But you're going to get the same, and Iran does the same thing here. We played against the 68th ranked team a lot of times, just because, especially during the pandemic, it was a lot easier to set up a camp against a team and play against them multiple times, just so you would have the chance of spreading out, playing multiple teams across the country or across the world. So then you can see I did that multiple times here, and threw in, again, doing the same thing, adding it in. So I had to do the same thing for a World Cup if they were the home team listed, World Cup if they were the away team listed, non-World Cup matches if they were their home team listed, and non-World Cup matches if they were the away team listed. So I had to do that 4 times. And then you can see I combine those together using a union statement here. So this combines all those results, whether they're World Cups or non-World Cup games, together to see whether they won, lost, or tied against whatever ranked teams in the world. So then what I did was I was coming down and I wanted to make an expected value for what the teams were going to do based on playing against certain ranking teams. So a win, a tie, and a loss. So a win is 3 points in the World Cup, a tie is 1 point, and a loss is 0 points. So I defined a point ranking to each one of these games as well. So you can see Wales lost against the 6th ranked team in the world. So they would have got 0 points from that game, or a tie with the second ranked team in the world and got 1 point. So on and so forth. So I wanted to make sure I go through there. And for this one, you can see I filtered it to only be the top 10 teams in the world because my analysis is going to hit that, which I'll carry on in just a moment. And so you can see what I did here. I didn't end up including this specific graph in my analysis, but I just wanted to show basically what the team's results were against top 10 teams in the world, because England is ranked 5th in the world currently. So we wanted to see how teams would be expected to play against a team of that quality. And you can see for Wales, for example, I have this filtered to Wales. You can see that they've won 1 game, tied 1 game, and then lost 8 times in the past 12 years, which is pretty crazy to think about, but it makes some sense since Wales is, I think, the 19th ranked team in the world. And you can see that Hex does this cool thing where you can filter by a variable up here or by a drop-down menu. So I can change this and it'll refilter and give us new data there, which we'll play with in our app later. So you can see it did the same thing for teams that are ranked 11 through 30 to kind of get that middle tier there, which is where the rest of the group lies between 16 and 20. So I filtered out a little bit larger to get a better sample size here. And then I came down and basically counted how many wins, losses, or ties teams had against a top 10 opponent, and then 11 through 30. And then did that graph again for 11 through 30. And then lastly here, I did average points against a mid-range team, average points against a top 10 team, continuing down. And then I did an expected value. So basically, we know that England's going to play 3 games against that mid-tier, that 11 through 30, because that's what the rest of the group is. And then the other 3 teams in the group are going to play 2 games against those type teams, and then 1 game against the bigger team of England. So we created that expected value, just did a basic statistics expected value, so the average points times how many games they're going to play, add those together, get our expected values here, which you can see is pretty close, as we expected by this group being pretty close together. So if I go and look at the app, Hex allows you to create an app here, which I will link inside of the description below, along with the blog post that you can read along if you would like. You can see all the graphics that I used here that were in our logic that we had earlier, but this just pretties it up so you can just see the graphics. So you can see that bar chart from earlier, our FIFA rankings, our top 10 filter. So again, like I mentioned before, if I change this to the United States, it's going to rerun all that code on the back end, and it's going to change this table and then change that pie chart below as well. So you can see it's running up there on the top with the little circles. So while that's loading, we'll scroll down. So same thing with mid-range results, and there's that expected points from group. So you can see that finally changed there, showing the United States and showing that we've tied 4 times, won twice, and lost 9 times against those top 10 teams as well. So again, this was just a little walkthrough of how I use Shipyard and Hex to take the data from Maven Analytics, put it inside of BigQuery, and then perform some analysis to put together a blog post on a preview of Group B of the World Cup. So I hope you enjoyed it. If you see any kind of workflow that you can maybe use inside of Shipyards or Hex, feel free to reach out to us or comment below, and we'd be happy to help you get started with that.